Welcome, welcome, welcome. Uncle Moses, welcome. Sarah, welcome. Femi, welcome. Dr. Dieter, coming to you from Fort Worth, Texas. Today, we're going to have a topic of conversation. We're going to be talking about how energy deficiencies lead to disease. Elizabeth, welcome. If you're joining me, please drop a comment in the chat. Let me know where you're joining from. My name is Dr. Dieter. I hold board certifications in two fields. I'm a board certified internal medicine physician, a board certified pediatrician also. I'm going to be talking to you guys today about how deficiencies of energy in our body leads to diseases. So welcome, welcome, welcome. If you're joining me from the Northeast, maybe you're joining from Connecticut, Massachusetts, Maine, Rhode Island, Vermont, New Jersey, New York, Pennsylvania, I want to welcome you. I'm going to show you in today's talk how all the processes in our bodies require energy to function. And when our cells do not have that energy to function, you have a malfunction. If you're joining from the Midwest, maybe you're joining me from North Dakota, South Dakota, maybe you're joining me from Nebraska, Missouri, Minnesota. If you hear your state, shout it out. Illinois, Indiana, Ohio, Iowa, Kansas, welcome, welcome, welcome. If you're joining from the South, maybe you're in Delaware, maybe you're in Florida, Georgia, maybe you're in Kentucky, Mississippi, Tennessee, Arkansas, Texas, maybe, Louisiana, Oklahoma, welcome, South Carolina, North Carolina, welcome. My name is Dr. Dieter. Today, I'm going to take you guys to understand how all the processes in our body, every cell, everything that happens in our body requires energy. Things do not happen in a vacuum. Lastly, if you're joining me from the West Coast, maybe you're in Arizona, maybe you're in Oregon, maybe you're in Washington State, maybe you're in Utah, maybe you're in New Mexico, maybe you're in Alaska, California, Montana, welcome, welcome, welcome. Okay, I'm going to start with this analogy. How many of you guys own your home or live in a home? If you own your home or live in a home, I'm going to use this analogy. Let's say that your sink breaks down, the kitchen sink breaks down, and you need to fix that kitchen sink. If you call in a plumber to fix in that kitchen sink, you have to pay that plumber to fix that kitchen sink. Let's say you have a backyard that has grass. You need to mow that backyard that has grass. You grab whatever mower you have. Some people's mowers runs on gas. Some people's mowers runs on electric. You need energy to be able to mow that grass. Whether it's a gas mower or whether it's an electric mower, you need energy. Let's say you want to do a paint job at home. You hire a painting company. You have to pay them. The point that I'm trying to make, think about your body as a house, as your home, and that everything that is happening in your home needs energy for it to happen. Mowing the lawn, you need energy in the mower to be able to mow the lawn. Fixing the bathroom sink, you need to pay the plumber, to be able to fix the bathroom sink. It's the same with the body. I'm going to use that analogy. Every cell in the body requires energy to function. Every single cell requires energy. And when we do not have that energy, then what happens is that the cell malfunctions and critical systems break down. So today, I want to take you and really explain, why that is important and how energy deficiencies then lead to diseases. So, what I'm going to do as usual is I'm going to start. I'm going to go to the whiteboard and we'll talk. So I'm saying that energy deficiencies in our cell, in our body, leads to diseases. And I want to use a fancy medical term here which is the same thing as energy deficiency. Energy deficiency in fancy medical term is what we call metabolic dysfunction, right? Metabolic dysfunction. And the statistics show that in the United States, 9 out of 10 Americans living in the United States have metabolic dysfunction, have an energy deficiency. Yeah, to be able to understand a little bit more about metabolic dysfunction, it's important to understand what a metabolism is. Metabolism is just simply how the body makes energy and uses energy, okay? That's what metabolism is. So that's why in simple terms, metabolic dysfunction is just the same thing as energy deficiencies. These are the same term. This term, metabolic dysfunction, is similar in layman's terms to energy deficiency. So if your body, when we eat, there is energy that is trapped in food. When we eat, that energy that is trapped in food, that is harnessed in the food, has to be converted into energy in our body that our cells can utilize, our cells can use. The conversion of that food energy, maybe energy from an apple, to cellular energy in the body that I can use, is called the conversion of that energy, from cellular and from food energy to cellular energy is called metabolism. How the body is transforming food energy into cellular energy that could be used for the body. So in a sense, you could also define metabolism as how the body converts cellular and converts food energy into cellular energy. So if the body is not able to take food energy and convert it into cellular energy, we say you have an energy deficiency. Or if the body is not able to make energy and use energy well, we say you have energy deficiency. So I want to reiterate the point again. If you're just joining us, my name is Dr. Dieter. I hold board certifications in 2 fields. I'm a board certified internist, a board certified pediatrician. Today, the purpose of my talk is to take you to understand how most of the diseases that we deal with all come from deficiencies in energy. And I'm going to give you a simple definition of a disease. But first, I want you guys to first understand how the body makes energy. It will be important to understand how the body makes energy for you to understand how the body goes to being now unable to make energy, the dysfunction. So it's important to understand the function before you understand how things broke down or the dysfunction. So how does the body make energy then? Let's see. So the body makes energy. Central to our body making energy is a hormone called insulin. How many of you guys have heard of the hormone insulin? If you're familiar with insulin, drop a comment in the chat, insulin. Many of you should be, because insulin sits critical, in our functioning. And when some people, when they hear insulin, they automatically think diabetes. And I understand insulin is related to diabetes, but insulin is way more than diabetes. So what insulin is insulin is a hormone, and it's a hormone that is produced by a gland called the pancreas. So insulin, the reason I'm talking about insulin is because I want to link it to it is produced by the pancreas. I want to link it to energy deficiency or energy production. So the pancreas is the gland that produces insulin, and insulin is a hormone. Now, how do we make energy? Remember, I was saying that it's important to understand how the body makes energy to be able to understand how the energy becomes deficient or insufficient. Now, Insulin, the hormone produced by the pancreas, sits central in making energy, very central, right at the peak. And how does insulin do this? The job of insulin, and I'm going to use, let's see. So this is what insulin does. The major job of insulin is to try to mobilize glucose out of the blood into the cell. You see, when we eat, so for example, let's say I eat an apple. After I've eaten that apple, the energy that is trapped in that apple, what happens is, absorption occurs. It goes through digestion in my GI tract. After digestion in the first part of the GI tract, it now goes into the small intestine where absorption occurs. The end product of absorption always is the release of glucose in the blood. So I eat an apple. That apple goes through digestion. And after digestion, the apple goes through absorption in the small intestine. And after absorption, the result of it is the release of glucose into the blood. In the blood. That's the process. I eat an apple. The apple goes through digestion, absorption, and release of glucose into the blood. So now this is where insulin comes in. When glucose is released into the blood, the job of insulin is to now mobilize that glucose out of the blood into the cell so that energy can be produced. And how does it do that? I'll show you how it does that. So, this is what insulin does. You now have glucose that has been secreted in the secreted in the blood after absorption. The job of insulin is to now mobilize that glucose, to mobilize that glucose out of the blood into the cell. That glucose gets into the cell. This is the cell. So when glucose now enters the cell, there is a very special organelle in the cell called the mitochondria. A very special organelle in the cell called the mitochondria. The nickname of the mitochondria is called the powerhouse of the cell, and you will see that here. So insulin's job, it now mobilizes that glucose out of the blood into the cell. When the glucose gets into the cell, the glucose is shunted into the mitochondria. When the glucose is now shunted into the mitochondria, it goes through a complex series of reactions called the electron transport chain. And when it goes through that complex series of reactions in the mitochondria called the electron transport chain, what happens is the end result is the production of an energy molecule called ATP. ATP simply stands for adenosine triphosphate. Adenosine triphosphate is the energy molecule. ATP, I'll just put that here, adenosine triphosphate. So that's how we make energy. Remember, I started this by saying that every cell in the body requires energy to function. There are several different functions in the body that have to happen. And those things we need to pay with energy. Just like I say, you own a home and you need to mow the grass in your mow your lawn. You may have a lawnmower that uses electric. You may have a lawnmower that uses gas. You need energy to be able to mow your lawn. So things in the house that have to happen will not just happen by themselves. You know, somebody needs to do somebody, do something, dispense energy, dispense time, dispense effort to have that done. If you have a meal, you know, with the family, after the meal is done, the dishes are dirty. The dishes don't just clean themselves. You need to dispense effort, energy to be able to clean the dishes, put them in the dishwasher. It's the same thing with the body. Everything in the body needs energy, and sitting central at the production of energy is insulin. So without insulin working well, you know, you will not have energy production. So that is it. Insulin mobilizing glucose into the cell and resulting in energy. That energy now is considered to be the cash for the cell to pay for everything. It is ATP. It is the energy currency, you know, of the cell. That, okay, the cell needs to repair DNA, you pay for it with cash. Okay, the cell needs to clean up waste, it will pay. Like cleaning up waste it's like maybe washing the dishes. Okay, it'll pay for it with cash. Okay, the cell needs to move something from this part of the cell to the other part of the cell. It needs to. So for example, you know, you're in your living room, you're like, okay, maybe this table should not be in this direction anymore. Maybe we should turn it to this direction. You need to move it, you know, from this direction to that direction, or from one end. Or maybe this table doesn't fit in this room. Let's move it to the other room. You need to dispense energy to carry that table, to move it to the other room. I'm using these analogies to simplify, to make you guys understand that our body is like a house. Everything in the house that needs to be done will not just do itself. You need to dispense effort to do it. You lifting that table up from one room to the other, you're dispensing energy. So energy is needed, you know, for the cells to be able to do their functions. And without that energy, when you do not have that energy, then you develop diseases. I'm gonna flip back, make sure that you guys are following me, you know. And if you're following me, then what I want to do next, you know, is to go through with you guys, you know, 7 energy dependent functions of the cell. I want to talk about 7 different functions that the cell needs energy to be able to. In our body, there's 7 categories of functions that our cells need to do so that things operate smoothly. When our cells are not able to perform those 7 categories of functions, we have diseases. So I'm going to go back to the board, you know, and I'm going to write those 7 categories. And then after that, what I'm going to do is I'm going to use 3 of those 7 categories to illustrate to us how those 7 categories, how the energy deficiencies because of that lead to disease. So let's go back to the board and so let's say I flip you guys back. All right, let's go back to the board. So the very first category, you know, that the cell, this right here, right now, 7 energy dependent functions. So I'm gonna go 7 energy. Something else. 7 energy dependent cell functions. So it means that without energy, these things are not going to work well. 7 energy dependent cell functions. Let's go. The first category, the very first one, that the cell needs energy to is what we call make proteins. The second one that the cell needs energy to is to repair and replicate DNA. The third one is what we call cell signaling. Cell signaling. Cell signaling simply means that the cell is trying to determine what to turn off, what to turn off. What goes where, not only what to turn off, what to turn off, what to turn on. Is like, okay, the stuff that I need to turn off, when do I turn it off? The stuff that I need to turn on, when do I turn it off? Turn it on. So things like that all fall in the category of cell signaling. They require energy. The fourth thing is transport. Sometimes, transport of molecules. Sometimes you have a vital molecule that is produced in one part of a cell and needs to be transported to another part of a cell where it's going to carry out its function. Transport of molecules and material across the cell. And then the fifth point is what we call homeostasis. Homeostasis is just simply maintaining a constant. It's just like maintaining a constant environment where the cell could work. You see, in our bodies, you need to have a certain level of pH for your cells to work, a certain temperature for your cells to work. So homeostasis is just making sure that conditions are right for the cells to work. The pH is good, the temperature is good, things like that. And then the point number 6 is cell cleanup. Cell cleanup. So taking care of waste. And point number 7 is chemical reactions. So this right here are 7 energy dependent. Everything that happens in your body, everything falls under these 7 categories. That's what the cell is doing all the time. Making protein, repair and replicate DNA, cell signaling, transport of molecules and materials across the cell, homeostasis, which is maintaining a normal working environment, maintaining a normal working environment, and then cell cleanup, taking care of waste and chemical reactions. All these things require you to pay for them with ATP, energy. And when you do not have that energy, these processes cannot take place. And when these processes cannot take place, you now develop a disease. What I would like to do is, I would like to take the first 3 in the interest of time. I would like to take, make proteins, repair and replicate DNA, and cell signaling. I want to show you guys how all of this, 1, 2, 3, coming from the deficiency in energy, result in disease. I'm gonna flip back over because I have a question to ask you guys. Now, how many of you guys on this, how many of you guys have high blood pressure? If you have high blood pressure, drop a comment in the chat, high blood pressure or BP. Or if you know somebody who has high blood pressure, drop a comment in the chat, BP. High blood pressure affects 1 out of every 2 Americans. So 50% of people living in the United States has high blood pressure, 50%. And the sad thing is that about 1/3 of the people who have high blood pressure do not know that they have high blood pressure. Now, what I want to do, the reason The reason I ask that question is because, great. The reason I ask that question is because I want to show you how high blood pressure is linked to energy deficiency, the lack of energy. Because your cells cannot make energy well, you have now developed high blood pressure. So stay with me. For those of you who said you have high blood pressure, I want to go and show you exactly how that happens. Now, we generate, I'm going to forgive me, but I'm going to clean this to be able to illustrate what I want to illustrate to you guys. Just remember the premise of this talk, that energy deficiencies is the cause of all our diseases. Energy deficiency is the cause of all of our diseases. So we're going to take how the very first point, make proteins. Make proteins. One of the functions of the cell, how that leads to high blood pressure. We generate our blood pressure from the artery. This is how your artery should look like. Your artery should look like this. Okay? That is your artery. We generate our blood pressure from the artery. Now, inside the walls of the artery is a very spacious cell, that line that sits around the wall of the artery like this. It's a very spacious cell that lines the walls of our artery. That cell, the name of that cell is called the endothelial cell. Now, the endothelial cell has a very special job. What is its job, you may ask? The endothelial cell produces a very special protein or signaling molecule called nitric oxide. Okay? The job of nitric oxide is to cause what we call vasodilation. It goes and stretches and opens the diameter of this artery and causes the diameter to be wider. So nitric oxide, when it's secreted by this cell, its job is to come here and cause a pushing out of the diameter of the artery, to push the diameter of the artery out. When it pushes the diameter of the artery out, instead of the artery now having this diameter in length, when nitric oxide exerts its effect on the artery, the diameter of the artery now looks like this. A wider diameter, it is now wider compared to this. So this wider diameter compared to this, when the diameter of the artery is wider, the pressure, I'll use P, the pressure in the artery is lower because the diameter is wider, and the diameter is wider because nitric oxide has exerted its effect on it. So that is the job of the endothelial cell, to produce nitric oxide, that nitric oxide to go and expand the diameter of the artery and cause the diameter of the artery to be wide. Because the diameter of the artery is now wide, it causes the pressure in the artery to be low. And that's how, nitric oxide helps us to keep a normal blood pressure, a normal or a low blood pressure. Now remember that I said that every cell in our body needs what? Energy to function. So this endothelial cell, it cannot just produce nitric oxide, like magic in a vacuum. It needs to pay for that with energy. It needs ATP, it needs energy to be able to produce nitric oxide. So let's say that normally this cell requires a certain amount of energy to produce, let's say 100 molecules of nitric oxide. And now you have a deficiency of energy because you're not having appropriate insulin signaling to result in energy. And instead of 100 molecules, let's say 100 molecules of nitric oxide is going to exert this effect on the artery and cause you to have a normal blood pressure. But now you have a deficiency of energy. And in that deficiency of energy, you do not have enough energy for this endothelial cell to produce 100 molecules of nitric oxide. And as a result, the endothelial cell is only able to produce, let's say, 40 molecules of nitric oxide. So a lower amount of nitric oxide. If 100 is needed to keep this artery this wide, and you have only produced 40 molecules, those 40 molecules are gonna cause that artery, not to open as much as the 100 molecules too. So in that case, now you're gonna have a blood vessel that because you only have 40 of nitric oxide here, this blood vessel is now, instead of looking yay big, is going to look like that. The diameter of that is much more smaller, a smaller diameter. Why? Because you did not have enough nitric oxide. Why didn't you have enough nitric oxide? Because there wasn't enough energy available to this cell to produce enough nitric oxide. So there is a ripple effect now resulting in not enough widening of the artery. And when you do not have enough widening of the artery, the pressure in this artery is high, and you have high blood pressure. Very simple. That's how a deficiency of energy can result in high blood pressure. Every cell in the body requires energy to function. You don't have that energy, you pay the consequence. And that's how high blood pressure develops. As simple as that. Now, I'm going to switch over. So for those of you who have high blood pressure, and if you have high blood pressure and you're on any medications for it, drop a comment in the chat. I have good news for you, because if you reverse the energy deficiency that caused the high blood pressure will go away, and you will no longer have a need for your blood pressure medications. Your blood pressure is going to improve because your endothelial cells are now producing enough nitric oxide. So if you have high blood pressure, there is good news for you. I can help you get off your blood pressure medicines by helping you to restore the energy balance. The second thing, thanks for your comments. The second thing I want to talk about is the second point: repair and replicate DNA. Repair and replicate DNA. So what I'm doing is I'm taking the first three energy dependent functions of the cell, and I'm showing you how those energy dependent functions are resulting in diseases. So when I talk about this, I'm going to talk about cancer. A lot of people think that cancer is bad luck. Adult cancers is bad luck. I'm here to tell you that when you have an adult cancer, whether it's colon cancer, whether it's prostate cancer or breast cancers, that science now shows that cancer, a good chunk of cancer is not due to bad luck. a good chunk of cancer, hear this guys, is due to energy deficiency in the body. A good chunk of adult cancers come from energy deficiency. Or you may think, or have bad luck, pancreatic cancer, what have you. No, 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 no. Our cells need energy to function. When they don't function well, you can have a high risk of cancer. And I want to explain to you how, energy deficiency results in cancer. Let's go to the board again. Now remember that the second energy dependent function of the cell is to make and repair DNA. Make and repair DNA. I'm going to clean this up. So the second is to make and repair DNA. Make and replicate DNA. I beg your pardon. Or to repair DNA and replicate DNA. That's the second function. So let's just say repair DNA. Repair DNA. All right. So let me show you guys, our DNA is wrapped up in a double helix structure like this. This is how our DNA looks like. We call this a double helix. The DNA is wrapped up like that. In the DNA that is wrapped up like that are genes. The genes right here. The genes inside the strand of the DNA right there. Those genes are the genetic code that determine the production of many different things. In your body, a new hormone, a new protein, a new neurotransmitter is being produced all the time. Enzymes, neurotransmitters, everything that our body needs, in terms of functioning, is being dictated and produced. Receptors is being dictated and produced by the genes coded in this DNA. Now, in order for our DNA to cause, so for example, I need, let's take an enzyme. Let's take the enzyme trypsin or pepsin. Pepsin is used to digest protein-rich foods, and pepsin is found in the stomach. When I eat, let me say I eat a New York steak, I need that enzyme to digest the proteins from it. That enzyme is coded and made by the DNA. So for the DNA to now make that protein, that enzyme, to be able to digest that steak, what happens is there is a process, where the DNA unwinds, to be able to expose these genes in here. So it is wind like that. It needs to unwind to expose the gene. So it does this. So it unwinds like this, to expose the genes. And the remaining part of it may remain wound, but, it unwinds in particular areas, to expose the gene. And then sometimes that unwinding could go right down. The unwinding could just be here. The unwinding could be right down or span the entire length. So it has to unwind to expose the genes that are here. When it exposes the genes that are here now, the protein now, through decoding can then be made. So now the enzyme can now be made. All right. Now, what I'm getting to is this process is happening so many times in our body. Wind, unwind. So when it does this, it has to then, after the enzyme has been made, it now has to revert back to its original shape. So the DNA is always getting It's wound, unwound, wind, unwind, wind, unwind. It's going from this to this, this to this, this to this all the time. So you will agree with me that that's a lot of motion. When you have a lot of motion like that, you're going to have wear and tear. It's just like if I have a door, that door needs to always be open and close, open and close, open and close. The opening and closing of that door repeatedly over time is going to result in wear and tear of the hinges. The same thing with the DNA. They open and close and open and close and open and close to be able to produce, decode and produce the enzymes and neurotransmitters and what have you, result in damage to the DNA. So I'm going to put damage. Let's do damage with, it results in damage in the DNA. I'm just going to do that right here, the blue points here. And maybe damage in the DNA, those blue points there. When you have damage in the DNA now, a damaged DNA or mutation in the DNA damage normally can propagate into a cancer. There are many of us who have damage in our DNA and never know anything about it. Why? Because there are systems in place in our body to repair the damaged DNA. So repair the damaged DNA. And that repair of the damaged DNA requires, let me hear it, energy. You need energy to repair a damaged DNA. A damaged DNA is not just going to repair itself. You need to spend some energy to repair it. Now, if you do not have sufficient energy, then you cannot dispense that energy to repair the damages. And if you cannot repair the damage goes uncorrected or unrepaired. That damaged DNA now propagates into a cancer. And now you have colon cancer or you have pancreatic cancer, what have you. So that's why I was saying a lot of people may think that adult cancers are bad luck. But a lot of adult cancers are tied with energy deficiency. The other thing is that, you need, the cell also has to replicate its DNA. Replication, think about replication as multiplication, multiplication. So 2 times 2, 4. And then you now go to 4 times 2, 8. And you now go to 8 times 2, 16. The cell has to do that, to be able to replicate its DNA, to be able to do that. If there is an replication of the DNA also requires energy. And there are regulatory processes so that replication goes well. If you do not have enough energy for replication to occur, replication goes crazy. When replication goes crazy, instead of, you may have 2 times 2 is 4, instead of 4 times 2 to be 8, when replication goes crazy, 4 times 2 becomes 16. The math doesn't add up. Replication has gone crazy. 4 times 2 has become 16 instead of 4 times 2 being 8. And that is how you also have a cancer. Abnormal replication causing the growth in an abnormal growth in a cell, making it cancerous. Energy deficiency. When you have a deficiency in energy, you are at increased risk of having cancer. So adult cancers, I want you guys to hear this, are not because of bad luck. Yes, there's some people who carry, the genes for BRCA1, BRCA2, increasing your risk. I get it, I understand. I'm not dismissing genetics. But what I want you to take is that more than our genetics, the way we live that influences energy balance in our body increases or decreases our risk of developing cancers. That's it. I'm going to flip to the screen and see, are you guys following so far? You follow me so far? So that was it on how energy deficiencies lead to cancers if you do not correct the damage in the DNA. Thank you. The last thing I want to talk about is I want to talk about cell signaling. What goes on, what goes off, what to turn on, what to turn off, and when to do it, and how this is related to diabetes. Diabetes affects in the United States, diabetes affects about 34 million Americans in the United States. And I want to talk about cell signaling and group it together with energy, group it together with transport, to show you how those two things, when they're deficient, lead to. Somebody asked, how do you add energy? I'm going to discuss that, how those two things lead to diabetes. So I'll flip over, and so I'll lump this number 3 and number 4. Number 3 is cell signaling, and number 4, because they're linked together. Number 4 is transport of molecules. And I want to link this to the disease of diabetes. I'm linking this to diabetes. If you have diabetes or know someone who has diabetes, drop a comment in the chat, diabetes. This will be useful for them or useful for you. Now, I talked about cell. This is our cell. This is the cell. There is a special transporter. There is a special protein in the cell called a GLUT4. GLUT4, okay? That's a special protein. The job of that protein, of this GLUT4, is to come to the wall of the cell and open up a channel in the cell. This is a GLUT4 channel. Just think about this as GLUT4. It comes to the membrane and opens up, and then when it does, glucose now flows in through the GLUT4 and gets into the cell. Okay? GLUT4. Now, for GLUT4 to be able to make a migration from here to the membrane of the cell, signals need to take place. A signal needs to be given to this GLUT4. Hey, it's time for you to go. Remember, cell signaling is what to turn on, what to turn off, when to turn it on, when to turn it off. So a signal needs to be given to the cell. Hey, it's time, GLUT4, for you to go to the membrane, open up, because we need to receive glucose. That signal, to send a message, to send that kind of a message, requires energy. If there is energy deficiency, it jams the signals. The signals are not being able to be sent. It's just like you want to send a text message to a friend, and you do not have a Wi-Fi, or you do not have a good signal. The message cannot go through. If, let's say, you want the friend to bring you guys are meeting at the coffee shop for an assignment or whatever, and you want the friend to bring a special book so that you guys can review for that assignment, and you try to send that message using your phone, but you do not have any signal, that message cannot go. If that message cannot go, your friend cannot bring that book to you. Signaling. So GLUT4 needs a signal to be able to get to the membrane of the cell to receive glucose. If you do not have energy, the signal is jammed. The signal is never really given. The GLUT4 doesn't go to the membrane to receive glucose. Glucose does not enter the cell. Glucose now accumulates in the blood. And the accumulation of glucose in the blood over time results in diabetes. Cell signaling. The other thing is transport. So you may have, the signaling may be fine. The signaling or maybe just okay. You have enough, you have a good 5G or what have you to be able to cause that GLUT4 to go to the membrane. Okay. So let's say you're meeting with that friend at Panera for this assignment. You send the message to the friend, your signal goes through because you have 5G or whatever. Hey, don't forget to bring this book. Let's review it for the assignment. The friend says, yes, okay, see you there. All right. Now, the friend gets in their car and wants to come, and all of a sudden, the car has a problem. The car cannot start. The car cannot start. We're not going to go into why the car cannot start, but the car cannot start, and the friend is not able to transport herself to Panera to meet with you. So even though she received the text message, she has a transportation problem. So you may have the right signal, for GLUT4 to go to the membrane, but GLUT4 needs to be transported to the membrane. The transport of GLUT4 to the membrane requires energy. If the energy is not there, you may have the signal, but GLUT4 is not going to make it to the membrane. And if GLUT4 doesn't make it to the membrane because GLUT4 cannot be transported because of a lack of energy, you have the same issue. Glucose accumulates in the blood. Over time, you have diabetes. So, for the purpose of time, I could not go through all of the 7 dependent functions and show you how all those 7 dependent functions are related to diseases. But I've gone through 4. The first one of it was making proteins. I showed you how that is related to high blood pressure. The second one of this was repair and replicate DNA. I showed you how that is related to cancer. And the third and fourth, cell signaling and transport, and how that is related to diabetes. Now somebody asked, how do you repair, how do you restore energy? Energy is made by the mitochondria, right? We spoke about this here. When the mitochondria is dysfunctional, remember we have a cell, glucose got into the mitochondria and went through a complex series of reactions to result in energy. So the mitochondria helps to make energy. When the mitochondria is not working well, you do not make energy. So there's a simple way, to help your mitochondria to be able to begin making the energy it does. And the simple way is this: there is actually a nutraceutical product I'll talk to you guys about. And I want to tell you this, that food is energy. Food is medicine. The foods that we eat and what have you help to nourish our bodies and cause the normal functioning of the mitochondria. Food can also be poison. The foods that we eat could poison our mitochondria and all of that. So there is a brilliant company that has come up with a nutraceutical product that helps the mitochondria to be able to produce energy. And that nutraceutical product is actually 100% made from plants. It contains 2 things. It contains this chlorogenic tea and it contains this fiber. Chlorogenic acid is a very important phytonutrient. it has been shown in scientific research that chlorogenic acid goes and enhances the property of the mitochondria. It makes the mitochondria strong. It makes the mitochondria resilient. It makes the mitochondria flexible. It makes the mitochondria efficient in producing energy. So that right there contains chlorogenic acid. I've been taking this, and it helps your mitochondria to become efficient in restoring energy. The other thing is fiber. This is a fiber product made up of 5 different plants. We need fiber equally to be able to help our mitochondria to have efficient energy. So the 2 things work in conjunction with each other, strengthening, reinforcing each other so that you could have a good performing mitochondria. If you have a good performing mitochondria, you're gonna produce enough energy. If you produce enough energy, the diseases that come as a result of those energy deficiencies then go away. So that's what I will end with. And I'm going to show you guys a link, on how to get these products. I consume them myself. After learning about the energy benefits on it, I want to be in the best energy state of my life as much as possible. And so I made a conscious decision for me and my wife, a conscious decision that we are going to be consuming this every day, because it helps to keep our mitochondria strong, prevents our mitochondria from having inefficiencies in energy production, and it keeps us protected from developing the diseases that may come as a result of energy deficiency. I'm going to scroll over now, and what I want to do is I'm just going to, if you're wondering how to get those products that I just mentioned, I'm going to give you guys a link with this comment I'm making. If you were to copy and paste that link anywhere in any browser, you'll be able to get those products to begin reversing or restoring your energy balance. And I say this, when you have energy deficiencies, let me show you guys when you have energy deficiencies, caused by poor insulin signaling, it causes you to have a bunch of issues and diseases like this. So this is a chart here showing how energy deficiencies coming from insulin signaling causes you to have several different issues. And you can see high blood pressure, which I talked about. You could see cancer, which I talked about. You can see diabetes, which I talked about. I want to show you guys some pictures of some people, and I want to show you this. So when you have energy deficiencies, again, this is just showing you what can happen: obesity, high blood pressure, high cholesterol. So I want to show you guys first a picture of myself. So I had energy deficiency, and one of the things when I had energy deficiency is it showed up as being obese. I used to be obese, and this is a picture of me. In 2019, I was 220 pounds. Energy deficiencies will cause obesity. I did some things for myself, because as a physician, I felt guilty that as a physician, I need to look, I need to talk the talk and walk the walk. It will be hypocritical for me to be trying to inform patients about their health and at the same time not looking healthy. So I did some lifestyle changes, and after doing some lifestyle changes, I was able to drop 50 pounds, and after dropping 50 pounds, I went to looking like this with some lifestyle changes. But then when I learned about, how my when I on this picture, I still had some issues. Yes, I dropped some weight, but I was not operating at my optimal energy level in terms of my cells. So there were still some things I was dealing with. When I learned about the fact that some of the things I was dealing with were related to deficiency in energy, and that these products which I'm talking about can help restore that energy, what I did was I embarked on beginning to use the product, and in a space of 2 months, this is what happened to me. I went from looking like this to looking like that by just reversing my energy deficiency. I was able to lose 14 pounds, and for the first time in my life, I was in my ideal body weight. Another thing that energy deficiency does to you is that energy deficiency causes you to have cholesterol issues. This was my LDL, what you call the bad cholesterol. I had energy issues and my cholesterol was high. When I started using the product, this is 3 months down the road, my total cholesterol dropped from 207 to 138, dropping by 69 points. Dropping by 69 points, my LDL. And then this was my total cholesterol. My total cholesterol dropped by 64 points just using that. So those were some of the benefits for me. I want to show you some other people who had similar issues and have been able to reverse, after reversing their energy deficiencies, have been able to reverse some conditions they were dealing with. This is somebody who had swollen ankles and legs, migraines, arthritis. She lost 74 pounds, just restoring her energy balance with this. Her cells started working well again. Her arthritis is gone and looking different. That's a before and after picture. This is another person's before and after picture. They were down. They used to have diabetes and no longer have diabetes, had cholesterol, no longer have cholesterol, and look at the transformation in how they look. That was that. And now, this is somebody who had lupus. They had lupus and did not only have lupus, had rheumatoid arthritis. The point I've been making all over and all over again is that when you have energy deficiencies, the cell doesn't function. A simple definition for disease is a malfunction cell. And why did the cell malfunction? Because of lack of energy. So these people I'm showing you here, they had diseases because of energy deficiency. She had lupus, rheumatoid arthritis, and diabetes. All of those things are gone. She's lost 40 pounds. She's no longer on medications for lupus or diabetes or what have you. When you have an energy deficiency, it causes you to have inflammation. This is a lady before and after restoring her energy deficiency. Look at how younger she looks here. Very, very young. Just a transition, restoring energy balance. Energy balance causes, poor energy balance causes inflammation. When you're inflamed, it causes you to age. And that's why there's that huge transition. This is another picture. Somebody who had diabetes, high blood pressure, high cholesterol, and was able to reverse all of this by restoring their energy balance. There's so many pictures of so many people. This is my friend John. John had diabetes for 25 years and was able to restore his energy balance and is no longer diabetic. Some other pictures. This lady had pre-diabetes, cholesterol issues. She dropped 12 inches off her waist. So many stories before and after of a couple. Before and after. This lady, her energy issue led her to being diagnosed with early onset dementia. Early onset dementia. You see, the brain The brain is the most energy dependent organ of the body. The brain uses 80% of our energy. 80%. So you can understand that when there is an energy deficiency, because the brain is the most energy consuming organ of the body, when in deficiency, in shortage, the brain is gonna suffer the most. And so this lady that I'm showing you, this lady that I'm showing you here, she was diagnosed with early onset dementia, started forgetting things and all of that, energy imbalance. She heard about this. She heard about the product I was talking about and how her issues were related to energy deficiency, and she decided to take a chance. She had been on this for a period of 2 weeks. This lady was going down so quickly, her family members were actually planning on putting her in a nursing home. But after 2 months of being on this is her transition. If I saw this lady, her name is Sue. If I saw Sue and you told me Sue on the left looks like a grandmother, I'll say, yes, she does. She looks like one, smells like one, acts like one. But this is the same lady about 2.5 months apart. And if you told me that this lady is a grandmother, I will I may hesitate a little bit and say, it doesn't look that obvious. But that's what it is, guys. Restoring your energy balance. Somebody was asking, did I miss the link, guys? I don't know what that means. Now, I will end with this. Any disease that you have, whether it's diabetes, whether it's obesity, whether it's high cholesterol, whether it's migraines, whether it's PCOS, whether it's hypertension, all those diseases come from energy deficiency. Remember, the simple definition for disease is a malfunctioning cell. A malfunction cell, the malfunction occurs because of energy deficiency. You restore that energy deficiency, the malfunctioning goes away, those diseases go away. So I want to end, by just going to my profile and showing you guys one more link. If you're interested in giving this a shot, where is the link? Where is the link? Twilly, let me give you the link right now. I'm placing a comment in the chat. What I am link. So Tweety, that comment that I just placed in the chat is an answer to where is the link. If you were to copy and paste that into any browser, it will take you to where you can get the product. So that's the link. But I'm going to also show you right on here on my TikTok profile. So if you were to go to my TikTok profile right now, this is my TikTok profile. You were to go to my TikTok profile. Right here under my name, you're going to see links. If you hit that right there, it's going to, 2 links are going to come up. 2 links are going to come up. The first link and the second link is just my YouTube channel. By the way, if you want to learn more about all of this, I run a YouTube channel called Reclaim Your Health. You can watch videos on there talking about these issues. But that's the second link. The very first link is the link where you can get the product. If you just hit that link right there, it's going to take you directly, Twilight, it's going to take you directly, Twilly, to the manufacturer's page, the company that makes and sells the product. When you get to that page, all you need to do is to hit buy now. When you hit buy now, the correct product has been selected for you. All you need to do is just to go to hit add to cart. When you hit add to cart, you come to this page. All you need to do is to hit checkout. When you hit checkout, you're going to be able to order the product just like that. So if you run into any troubles, Twilly VW88, yeah, if you run into any trouble, please send me a direct message or what have you. I'll be happy to help you to be able to order that. So thank you guys for joining my live today. I look forward to seeing you guys again on another live. Bye for now. I don't see the link. Got it, thanks. Okay, Cleo, you said you don't see the link. I'll do one last thing. Cleo, I am putting this comment in the chat. And all you need to do, this comment that I just placed, copy and paste that in a browser, Cleo, and you should be able to order that. That's the link. Now, Cleo, if you run into any trouble trying to order this, you cannot find the link or you cannot use that, please send me a direct message. I'll be happy to work with you, even get on the phone with you. I'll be happy to do that to help you to be able to order that. Thank you guys for joining me today. Bye for now.